with that is used to distribute the fresh ventilation air to the bedrooms and living areas of the house. But when the house is really all finished off, and in many cases the basements are all done, how do we get the ductwork? We can go and hang the HRV on in the ceiling of the mechanical room, but how do you get all the ductwork in there now? And the controls that are associated with it, because typically there's timers or on-off switches in each of the rooms, like the bathrooms and things like that, to turn the HRV either on or into high speed or whatever. So it's not quite so easy to put an HRV, a really good installation into an existing house, because of all those complications with finished rooms and areas and that sort of thing.
So when we do a retrofit and we're obviously sealing up these houses a lot more than they used to be, are you saying like we must need to put something in there?
Yes. If you take an existing house that's fairly leaky and you now seal it up, that's a no-no, without at the same time addressing ventilation. And that's why the building code requires all of our houses to have ventilation systems in meeting certain standards. But in an existing house, if you now start to tighten it up, you don't have that same ventilation system. And that's why I said a little while ago, most existing houses are under-ventilated. People tend to turn on the bathroom fan when they're in there showering. As soon as they leave, they turn it off. Well, that thing should probably be running for another hour or something after you leave yet, just to get rid of all the moisture and other contaminants and stuff that are around there. And so most of our houses are under-ventilated, and we can use the existing systems that are there, bathroom fans, as long as they're run for a longer period of time. But because they don't move a lot of air and they're so noisy, they tend not to get used. So one of the options is to upgrade the fans that are there. Sometimes you can use the existing ductwork, but if you go with the new fans, they are more efficient as far as moving more air, and they tend to be quieter because they need to have some zone ratings now where the old fans didn't. So like I said, the old fans didn't move much air and were noisy. The newer ones are more quiet and they move more air as well. So that would be one option, is just to upgrade the fans that are there as a starting point. A better one is to use an HRV, and sometimes you can finagle things around so that you can get some ductwork up to the areas that you need. And we basically exhaust from the areas where the contaminants are, and high humidities and odors. And so we tend to exhaust from the kitchen and the bathrooms and maybe the laundry area, and then we supply to all other rooms in the house.
So like I thought I've seen HRVs in older homes where they're just hooked up to the furnace somehow, but that's not what you're talking about.
In some cases they use a simplified version where you have an HRV that will be in the basement, and because you can't get the ductwork excuse me, into the bathrooms and the kitchen, they will simply pull air from the return and put it back in again, one upstream and one downstream from the other. So they're effectively using the ductwork of the furnace to be able to take some of the stale air from the house, exhaust it outside, bring fresh air, and dump it back in again. So you would draw stale air from the return air of the furnace, run it through the HRV and out, and then the fresh air would be dumped back in, but downstream, so that it's not
The same air.
causing the same air, exactly. Yeah. So that would be a simplified version of how you would install an HRV into an existing house. But like I said, we can't just go in there and seal up your house, because it'd be like putting a bag over your head. You can't live in something that doesn't have some ventilation, some fresh air coming into it. You got to get rid of the pollutants that are in the house, from whether it's off-gassing from furniture or drapes or from cooking or hobbies or whatever it happens to be. Get that outside, and humidity as well, because humidity can cause us lots of problems. And at the same time, bring in fresh air from outside, as long as the source of the air is good. It's not coming from a driveway where you've got carbon monoxide from the vehicle warming up or something like that as well, right?
Okay, I've got more questions. Should I just keep firing? You want to take a turn now?
Well, yeah, I've got one. When we built our house, we were looking at whether we should do the Energy Star thing, but then you needed to be the builder piece, right, and then the Energuide. So at the end of the day, you're saying that Energuide, if you've got a media rating, basically that's kind of matching up with an Energy Star.
That's
right?
correct,
So,
yes.
So when the Energy Star process is all done, do you actually give it an Energuide, the house an Energuide rating?
We don't give it an actual Energuide rating, because the Energuide for New Homes rating system, see if I can back up a little bit. The EnerGuide for new homes rating is a performance.
Right.
It's done with software analysis and things like that, whereas the Energy Star standard has been, we did about 1,000 runs on different styles of houses, sizes of houses, and as a result we came up with a prescriptive standard that the builders build to in order to hit that 80 rating. Not every house will be exactly 80. There's a small band there. Some of them will be 79, some will be 82. On average, Energy Star houses are 80.
Oh, I see.
Okay, so, because it's sort of like driving from here to Regina. You set your cruise on 110, because I think it's 110 on the highway now. But when you're going down the hill at Lumsden, you're probably going to be doing 115. When you're going up the hill on the other side, you're probably going to be doing about 102. On average, you're driving 110 from Regina to Saskatoon, but
Right, yeah, and I could,
you know,
right.
so that's what Energy Star is. On average, Energy Star houses are 80. The odd one might be slightly under. Some of them will be a little bit over, but on average they're 80. So we can't give an exact label, rating label, to an Energy Star house because we don't know exactly what it is.
Right.
Whereas when we do the software analysis with plan analysis and the whole software side of things, we do know what it is, and that way we can give the actual rating label,
Okay.
81 or 85 or whatever it ends up happening to be. Okay?
Okay, so it's really the Energy Star is more kind of, you know, takes that kind of R2000 kind of concept and pushes it a little higher to say, okay, well, you know, we want to build more efficient houses. We need to instruct the builders or train the builders on how to build better
Right.
houses, right? And so here's the things you need to do.
Energy Star is
And at the end,
it's a little bit more builder, helps the builders out because they know going in what it is.
Right.
It's actually conservative, and I would venture to say that if we looked at those houses, most of them would be 80 and higher. But that's not to say that any individual house couldn't be a 79 or something like that. But because it's sort of on the conservative side, and most of the builders are doing a pretty good job and their houses are coming in pretty tight, which will make them more efficient as well. And so chances are that most of them are going to be 80 and higher. The odd one, depending if it's got a poor orientation for solar gain or something like that, could be in the high 70s. Okay? Okay, so that's sort of the difference between, this is a prescriptive process, this is a performance process. Okay? Does that answer?
Yep.
Okay?
When Dumont was designing this, when Dr. Dumont designed this house, he was probably stated many times that he thought about 75% of the success comes from design and about 25% comes from the actual construction. I don't think that was a scientific number, but maybe his way of saying that design was very important. And I kind of like that because you can, once you design the house, you can control that design and you can stick with that design. So all the things you talked about, we've got in this house. There's a lot of stuff that Dumont's put in here. And no matter how bad the construction is, you can seem to control that a little bit and keep it under control if it's a 25-75 mix. What's your observations from having seen all these houses and testing them? Is, you know, obviously the construction is a critical part on the air tightness.
Well, see, and that's the benefits of the third-party independent
Sure.
verification. If there's leaks there, you can't cover them up because at the air test we're going to find them.
Sure.
Okay, so if you're out there and you're slashing up the air barrier or you're not sealing it or you're not doing something or other, yeah, you can cover it with the drywall, but when we come back at the end, at completion of construction, and we do the air test, we're going to find out that it's leaking. And we can usually find out where the leaks are as well. So you're not going to be able to hide that. And I think overall, most of the trades out there are getting pretty good. They're doing a pretty good job of installation of the insulation. They got a pretty good job of the air barrier with the poly and the poly boxes and poly pans and all that other good stuff that goes along with it. Most of the mechanical guys are getting better on installation and balancing of HRVs and furnace and ducting and all the other good stuff like that. So in some cases, depending on if the design gets to be too complicated, I don't necessarily agree. Well, Rob is maybe exaggerating things because he's involved in the design end of things, so he would say 75% is on the design side. But if the design is too complicated, it's harder to achieve on site. And as a result, there needs to be more mentoring, more training and direction for the people that are on site doing the actual work to make sure that that design gets done correctly. So they do go hand in hand, whether it's 50-50, 75-25, it's really hard to put a percentage on it. But for the most part, the designs can pretty much be achieved. Once we get into more of the sophisticated stuff like the renewables, solar panels, PV systems, drain water heat recovery, some of those types of things, they're still pretty new for the most part in the marketplace, and probably that's where there needs to be more supervision and direction given to implement the design on site.
Okay, two more questions. So one is, you mentioned the rebates. My understanding is there's only one rebate and it's $1,000.
The basic rebate in Saskatchewan is $1,000 if your house rates 80 or higher.
Okay.
So that's on the Inter Guide for New Homes process. If it rates 79, your rebate is 0. If it's 80 or 81 or anything above that, it's still 1,000. Energy Star houses are looked at being 80 and up. R2000 is the same way, and for the most part, LEED houses would be there as well. Now that's the basic incentive. Beyond that, there's additional top-ups, if you want to call it. So first of all, the house has to hit 80 and achieve that first level. Then there's additional incentives for natural gas appliances. I think there's $200 to $500 or something like that.
It's like 100 and 150.
100 and 150, okay, for things like natural gas dryers, I think, and barbecues or whatever it happens to be. Then there's additional top-ups for drain water heat recovery. Again,
It's
these
like
are,
$100 or $150.
that's off the top of my head, again, something along like that.
Okay.
Then there's additional things you can get, like solar domestic hot water. If it meets, if it has a certain capacity, you get another, is it $1,000 for that system? And if you go to geothermal,